All right, we're back. I got this sheet from pre-calculus, and right here is horizontal asymptote. I figured out vertical asymptote. You just set the denominator equal to 0, right, and then solve for x. So VA equals y equals x, or no. 0 equals x minus 2 plus 2 add to both sides. So there's a vertical asymptote at x equals 2. All right. Now for the horizontal asymptote, there is no horizontal asymptote, but there could be a slant asymptote. Be right back while I figure out how to solve for a slant asymptote. Alright, I'm back. I don't think that there's a slant asymptote, but just to be safe, I'm gonna be checking in the back of the book here. Alright, yeah, that's not a slant asymptote. It's something though. Alright, so this is everything that we can get from the original equation, so now we're going to take the derivative, right? So f prime of x, actually, you know what, no, we'll make sure that this is neat. We'll section it off here, give it a little dashed line. F prime of x equals, gosh, okay, well, we're going to have to do quotient rule here. So bot d top, which is 0, I guess we'll keep it, minus top d bot, which is 1, all over x minus 2 squared, and then the minus 3 cancels. So now, put parentheses around there. So that just becomes negative 1 over x minus 2 squared. All right, now when solving for critical numbers, we need to consider the denominator as well. So set that equal to 0, because setting the entire function equal to 0 gets us nothing. So x minus 2 squared equals 0, square root, x minus 2 equals 0, plus 2 to both sides. So we have a critical number at x equals 2, right? Set up our intervals, negative infinity, comma 2, 2, comma infinity. And now let's find our calcs. All right. So we got our calcs here. Oh yeah. And we are going to plug in the numbers in these intervals into this equation here. So negative 1 over, we'll do 0 to make it easy. Actually, no, the denominator is always going to be positive. Wait. If the denominator is always going to be positive, then the function's just always going to decrease, because the numerator is negative. Put away your calcs. It's just decreasing permanently, which means that there is no minimum and there is no maximum. Unfortunate. So the function is just always decreasing. Isn't that fun? So I think this means that we're going to move on to the second derivative so we can figure out concavity. So we'll put the terrible dashed line there. F double prime of x equals, looks like we're gonna have to do quotient rule again. All right, so bot d top, that just zeroes out, minus negative 1, and then the derivative of the bottom, this is going to be chain rule, so 2x minus 2 times 1. That's a lot of parentheses. All right, so f double prime of x equals, these two negatives just become a positive, so that's 2x. Oh, I forgot one small thing. Silly me. all of that will be over x minus 2 to the power of 4 because it's bottom squared, and since that's already squared, squaring that again just makes it to the power of 4. All right, but now that becomes f, I erased a bit too much there, f double prime of x equals 2x minus 4 over x minus 2 to the power of 4. Actually, hold on, before I do that, we're gonna cancel out these terms here. So that becomes just a 1, and that becomes a 3, which should leave us with 2 on top, and a x minus 2 cubed in the denominator. And then with this, we can figure out concavity. POIs are going to be, not POIs. What is that? Critical number? I don't know. We're gonna use x equals 2 for our intervals. So negative infinity, comma 2, 2, comma infinity. Although first, all right, just wanted to make sure that we weren't on any interval. All right, so now we're gonna plug that into, we don't need to plug it into our calcs, do we? No, we'll plug in a 0 down here, so that's gonna get us 0 minus 2 cubed, which is just negative 2, well, no, it's 2 over negative 8, but it's a positive over a negative, which gives us a negative, so that's gonna be CD, concave down, and then plugging in a 3 here would get us a 1 cubed, so 2 over 1 cubed, positive over positive, positive, concave, up. This is all of our information. Let's graph. All right, so we'll set up the graph here. We'll put it out to, well, we need to put it out to at least 3.5 because that's where our x-intercept is. I forgot to put the dots above these. So we'll bring it out to 5, actually. Maybe? I don't know. Oh, hold on. One more thing before we start graphing. This is a possible POI at 2, comma, and then we plug that back into the original equation, and let's see what we're gonna get. It's nothing. All right, perfect. So, never mind then. I guess it's 2, comma, undefined. 2, comma, perfect. All right. This point, I guess, doesn't really matter then, but the intervals do still matter because they still help determine concavity. So let's start out. We have a vertical asymptote here. You can't see it because of, or no, we have a vertical asymptote at x equals 2. So we'll make this 1, there, yeah. So at x equals 2, which would be here, we have a VA, right? So that's our vertical asymptote. And then at 0, negative 3.5, which is on this side, we cross the x-axis, and then we'll go up 3 here. All right, well, my pencil tip broke. 1, 2, 3, and the third one is a bit off. All right, 2.3. It's gonna be like here, or no. Wait, did I mess that up? Did I switch those around? Hold on, give me 1 second as I realize my mistake. All right, guys, I bring good news. I made a little whoopsie daisy. So these are actually switched around. That's the y-intercept and that's the x-intercept. Silly me. So actually, the points are instead gonna be, now we have to expand. We'll just make it 4 on all sides, I guess. 3, 4, negative 3.5, or 0, comma, negative 3.5. And then 2.3, comma, 0. We'll be back in the next part.